Hey everyone, today we're going to jump into a skill that is just a core fundamental part of working with data. We're talking about calculating running totals, or as you'll often hear them called, cumulative sums. Trust me, once you get the hang of this SQL technique, you're going to start seeing places to use it absolutely everywhere.
I mean, just think about it. How do you track progress? It could be sales piling up through the month, a user's activity growing over their lifetime, or even just inventory levels changing day by day. We're constantly trying to understand not just a snapshot, but the story of how we got here. And that's exactly what a running total lets you do.
All right, so here's the game plan. First, we're going to set up a simple challenge using a gaming example to make it really clear. Then, we'll solve it two different ways: the classic, old-school self-join, and the much more modern window function. We'll even put them head-to-head to see which one's better. And then we'll wrap up by talking about why this is a true SQL superpower you need in your toolkit. Okay, let's dive in. To make this whole thing less abstract, we're going to work through a really simple, practical problem. Let's pretend we're data analysts for a gaming company. Our mission, should we choose to accept it, is to figure out for any given day a player logged in, how many games had they played in total up to that point. So this is what we're starting with. A simple table, let's call it activity. Each row tells us a player, a date, and how many games they played on that specific day. It's like a bunch of individual snapshots. But what it's missing is the bigger picture, right? The cumulative story for each player.
And this is our finish line. This is what we want. We need to create a new table that has this awesome new column, games played so far. And that column needs to show, for each player on each day they played, the grand total of all games they've played up to and including that very day.
Let's just walk through the logic for player one by hand real quick. So on their very first day, the running total is easy. It's just that day's games, 5. Okay. Then on their next active day, we take the old total, 5, and add the new games, 6. That gets us to 11. And on their third day, we take that running total of 11, add one more, and we end up at 12. The key here is that each new calculation builds on the last one, but it has to stay within that specific player's history.
All right, so we know what we want. How do we get a database to do this for us? Let's start with the classic approach, what I like to call the brute force method, the self-join. It's been around forever, and you know what? It gets the job done. So what on earth is a self-join? It sounds complicated, but it's really not. You just take your table and you join it to itself. That's it. You basically pretend you have two copies of the same table, give them different nicknames like T1 and T2, and then you can start comparing rows from the first copy to rows in the second copy. It's a pretty clever trick. Okay, here it is, the actual query to pull this off with a self-join. I know, at first glance, it might look a little intense. You got these T1, T2 things, a where clause that seems to be doing some magic, but don't worry. We're going to break down exactly what each piece is doing. So here's how this beast works. For every single row in our first copy of the table, T1, the query looks at the second copy, T2, and asks a question. It says, hey, for this exact same player, find me all the rows that happened on or before this date. Then it just sums up the games from all those rows it found. That's how it builds the total. The key thing to notice is that it's building that sum from scratch for every single row. It's clever, but man, that is a lot of repeated work. Now, let's look at a much cleaner way to do this. The self-join works, but modern SQL gave us a beautiful tool designed specifically for this kind of problem: window functions. Seriously, these things are a total game changer. So a window function lets you do a calculation across a whole set of rows that are related to the current one. But here's the magic. Unlike a group by, it doesn't crush all those rows down into one result. Nope. It gives you a value for every single row based on the window of data you tell it to look at. It's like having this little sliding calculator that can peek at the rows above it and just look at the query. It's so much shorter, so much easier to read. All the magic is tucked inside that one over clause. You can literally read it like an English sentence. Get me the sum of games played over a window that's partitioned by player and ordered by date. It perfectly describes what we want to do. Let's just pop the hood on this over clause for a second. Partition by player ID is like building little walls between each player. It tells SQL, hey, when you're calculating for player 1, only look at player 1's data. Then order by event date sorts all the activity for that player from oldest to newest. And finally, sum just walks down that nice sorted list, adding up the values as it goes. It's efficient, it's clean, it's purpose-built for the task. So there we have it. Two different methods, both getting us the exact same result.
You've got the old school self-join and the sleek, modern window function. So the big question is, which one should you actually be using? Let's put them head to head.
And yet, this comparison tells the whole story. For readability, window function wins, hands down. It just says what it does. For performance, oh boy. On a really big table, that self-join can become painfully slow because of all that recalculating. Window functions are super optimized and blazing fast. And honestly, the logic is just way simpler to write and to come back to 6 months later and still understand. So the verdict is pretty clear, right? Well, it's cool to understand how a self-join can do this. For any real-world modern data work, you should be reaching for window functions. They are the right tool for the job. They're faster, they're cleaner, and they are way more powerful. Okay, so we solved a little problem about video games. But why is this skill so important? I'm calling it a superpower for a reason. Because knowing how to calculate running totals unlocks a much deeper level of analysis, no matter what kind of data you're working with.
I mean, just think of the real-world uses. You can track month-to-date or year-to-date sales revenue. You can keep a running tally of your inventory as things come in and go out. You can watch your user base grow day by day, or model how a bank account balance changes with every transaction. The possibilities are just endless. And that right there is the real takeaway. This technique lets you transform these lonely, static data points into a dynamic, compelling story. A story of progress, of growth, of change over time. It adds that critical dimension of history to your data. So the next time you're looking at a table of data, don't just see the snapshots. Ask yourself, what's the cumulative story here? What progress can I track? Now that you've got this tool in your SQL belt, what running total